Okay, so I want to go over the geometries of the molecules, the 5 different geometries that we're studying. Those geometries are linear, trigonal planar, we can call that TP, tetrahedral, pyramidal, and bent. Okay, so I want to go over those, some of the different situations that those might come up, some of the things to look for to help you identify those. The first one that we're going to talk about is linear. The easiest molecule to look at for this one is just hydrogen, H2. You have your molecule here, and there is one area of electron density. There's one place off that either of those atoms where electrons are found. So you have a straight line, so we go back to our linear. Okay, a little bit more complicated than that is CO2, where I have my carbon bound to my oxygen, has its lone pairs, bound to my oxygen, has its lone pairs. It's a little bit more complicated, but when we look, we see that we still have this straight line. There's electrons here, there's electrons here. They want to push away from each other as much as possible. The negative charges don't want to be next to each other, so they push to 180 degrees, and so we end up with a linear configuration for that carbon and those oxygens. Another case where this might happen is if you have hydrogen cyanide, where you have a triple bond and a single bond. Okay, we have the same scenario where we have two areas where we have my electrons. Okay, they're going to push away from each other as much as they possibly can and give me that 180 degree separation. So this is also linear. So you have 3 different cases where you would have a linear configuration. Next we would get into our trigonal planar. Idea, and the simplest one for that is BH3. So let's look at BH3. We're going to put boron in the middle, hydrogen, hydrogen, and hydrogen. We have the same idea here where we want to separate these electrons by as much as we possibly can. With this one, instead of 2 like we do in the linear, we have 3 areas where we have electrons. Okay, so because we have 3, we can't get to that whole 180 thing. We're only going to be able to get to 120 with this. Okay, and this is one way that you can do that. And boron and everybody in his period on the periodic table, or his group in the periodic table, follow this. The other way that you can get to this is if you have a double bond, okay, which would give us back the here, here, and here. We have 3 areas around that carbon. They're going to each push away from each other, so we're going to see that 120 degree separation, and we'll call this TP, or trigonal planar. Okay. Tetrahedral is when instead of 1, 2, or 3 areas of electron density, I have 4. Okay, now it's really, really easy to look at this and say, oh, well, there's 90 degrees, there's 90 degrees, there's 90 degrees, and there's 90 degrees. That isn't exactly what happens. We went over this in class, and I'll try to draw it as best I can here. They actually adopt a 109.5 degree difference. So there's your first one. The second one is actually going to pop out towards us, so that wedge is popping out towards us. And the fourth one is actually going to push back away from us. Okay, and that one, all of them are 109 degrees, 0.5 degrees instead of 90 and 180, because if we go back, to this idea, this bond and this bond are 180 degrees away from each other, which isn't fair because this bond and this bond are only 90. Right? Well, these ones are all the same. This is our tetrahedral. Anytime you have any element that has 4 bonds, you're going to have tetrahedral. That being said, if one of those bonds, NH3, okay, is a lone pair, we don't see him. So we change the name to pyramidal. And if 2 of them are lone pairs, okay, so we still have 4 areas where we have electrons, but 2 of them are lone pairs, we're going to call this bent. Okay, we're going to go over some stuff in class, and we're going to be working on different things with this. If you are struggling with it, come in and actually build the models. Look at it, see it, so that you can get it in your in the back of your head what it should look like, and you can visualize this. It makes it a lot easier. Hope that helps, and I'll see you guys in class.